Hello everyone, am I audible?
Hello, hello.
Good evening, everyone. This is Manogna, and I'm the host for today's webinar. It gives me great pleasure to greet you with a warm welcome on the behalf of IEEE GRIT SB. IEEE is the world's largest technical professional organization dedicating to advancing technology for the benefit of humanity. The mission is to provide a platform for knowledge sharing, networking, and career development to the local technical community. For an engineer, a key part of the role is staying relevant and ensuring the competent skills are aligned with emerging technologies. IEEE GRIT-SB left no stone unturned in introducing students to innovative technologies and helping them to explore outside their curriculum. I take the honor I take the honor to welcome our speakers, Mr. Harish Neelam, Mr. Kaushik Sai, Mr. Pratap Kumar, Mr. Karthik Pampari, our seniors from EC. Today, our seniors are going to speak about their project, Melanoma Detection Using Deep Learning. Melanoma is a type of skin cancer that develops in cells that produce melanin. Melanoma has become more widespread over the past 30 years, and early detection is a major factor in reducing mortality rates associated with this type of skin cancer. Therefore, having access to an automatic, reliable system that is able to detect the presence of melanoma via a dermatoscopic image of lesions and or skin pigmentation can be a very useful tool in the area of medical diagnosis. Today, we are glad to have our seniors to speak on their project. With no further ado, I request Mr. Harish to take over the session.
Thank you. Thank you for the introduction. So, good evening, everyone. I'm Harish Neelam. On behalf of my team, I'm going to present our project melanoma detection using deep learning. We have done our project under the guidance of Dr. K. Padmavati ma'am. She was very helpful in each and every moment of our project. So, without any late, I'm going to present our project. So, we have taken to detect melanoma because it is one of the fatal cancers in the world, and if it is detected early stages, we can give treatment to the patients so that the patient's life is prolonged. There are many types of skin lesions, but we have chosen these 7 types of skin lesions: melanoma, melanocytic nevi, and dermatofibroma. So why melanoma? Because if it caught early, most melanoma can be cured with relatively minor surgery, uh, and our data also includes melanocytic nevi. It is the primary stages of melanoma, so it helps to catch the melanoma early. Firstly, machine learning. What is machine learning? Just we are giving the historical data which is already there to the machine so that the machine can learn from that and build, and by using the logical models, we can predict the output for the future things. We have used deep learning. In the deep learning is nothing but the outputs of the first layer is connected to the second layer as input. This tells how we have done our project. We have taken a data set and then we have splitted our data set and then pre-processed the images, selection, training, classification, and final decision is given. So we have taken our data set from Kaggle. There are many data sets. We have chosen this data set. It has 10,015 cancer images as shown. The data is non-uniform. It also contains the predefined data frames with 28, 28.3, and 8.8.3. So we have taken data set. So firstly, we have to see whether there are outliers or not. So we have done some data analysis like what age groups getting more melanoma. So if you can see here, the age groups of 55 to 60 and 70 to 75 in males or more, and in females it is almost same with 45 to 85 ages. And these graphs describe lesions versus count and gender versus count. So then we have split our data. We have taken an initial data set with very huge data, and that data is split into 80% data, training data, and then 20% testing data. And furtherly, the 80% training data is again split into 90% training data and 10% validation data. I'm going to say what is this 10% validation data is used for. So in order to train the model,
Harish, are you sharing screen?
wait. Sorry, everyone. Is my screen visible?
Yes, it is visible.
Okay. So I'm going to explain from this data analysis. So if we can see these graphs, males from 55 to 60 and 70 to 75 are more prone to melanoma, and females from 50 to 85 are more prone to melanoma. And these graphs describe lesions versus count and gender versus count. And the next, after taking data set, we have split the data into two types: 80% training data and 20% testing data. 80% training data is used to train the model so that the machine can learn what we are teaching it, and that data is furtherly divided into 90% training and 10% validation data. And the rest 20% testing data is used to find the accuracy, how accurately our model is. So in order to train the model, firstly, we have taken training data and validation data. This validation data is used to test the training data while training. So how this training is done? Image pre-processing, segmentation, feature extraction, and classification. Image pre-processing is nothing but just brightness effects and contrast effects so that the image is clearly visible. And segmentation is nothing but dividing unwanted and wanted portions. And then feature extraction, getting the important features from the image, and then classification, whether it is melanoma or not. So in order to do all this process, firstly, we have to convert our image to array. How it is done? If we take an image, every image is in the form of three layers: RGB, red, green, and blue. So if the image is of totally red, then it has the values of 255, 0, and 0. And if it is green, 0, 255, 0. After we get these values of RGB from the image, we can calculate the value of pixel by this formula, R into 256 square plus G into 256 plus B. So like this, we'll get the image to array. So if you can see this, the black is considered 0 and the white is considered 255, and magenta somewhere here 105, and yellow 226 goes on. So now we have converted image to array. So then we have to get the features from the array. In order to do that, we used convolution. Convolution is nothing but applying the filter to the image so that we can get maximum important features from that. So these two are the filtered image, high pass filter and low pass filter. So how this convolution happens exactly? If we take the left side one, 6 by 6, an image, and 3 by 3 is a filter. So this filter is applied throughout the image, 3 by 3 matrix, and the values are found, like 3 into 1 plus 0 into 0 plus 1 into minus 1, and so on. We'll get the value -5. And then next, we'll slide that filter one step, and then again we'll find the value, we'll get -4, and so on we'll get. And we got a 4 by 4 matrix, a filtered image. So we also used pooling. Pooling is nothing but reducing the image size so that the features are increased. If you can see here, 4 by 4 image is reduced to 2 by 2. There are two methods, max pooling and average pooling. Max pooling is taking an max value from the array. and average pooling is taking the average of all the pixel values. So this is the process: convolution and pooling, taking an image and getting multiple convolution layers, and then for each and every convolution layer, we will get multiple pooling layers, and those are finally connected to fully connected network. So these are the models we have done so far: CNN model, AlexNet model, exception, ResNet, efficient net, custom, and simple models. We are going to discuss that. Then, so firstly comes basic CNN model. In this, we have used two convolution layers and pooling, and so on. So like this. The first line, from this line, we can get the CSV file we want, and this is initializing the CNN model. If you can see, convolution layers 2 and 1 pooling layer, and in each convolution layer, we can include how many filters we want. So this is just random, 32 and 64, and the kernel size is 3 by 3, as we have seen the filter size. So after each and every convolution layer and pooling layer, the image size is modified by this formula. So if we have taken our initial image size as 7500 and 7500, so what happens to that image size after each convolution layer and pooling layer is, we'll take input size plus 2 into padding. Padding is nothing but adding extra zeros around the matrix, and filter size, and stride is nothing but sliding. So after doing the first stage convolution, we got the same size, but after pooling, as I said, the image size reduced to half, so it gets to 37 by 50. So finally, we'll get all the parameters connected into fully connected network. I have said that there are many filters in convolution layers. So like these, in each convolution layer, there are many filters applied. So these are some of the filters that are applied. After doing this basic CNN model with epochs 50 and batch size 20, epoch is nothing but period, like first 20 and the next 20 and the next 20, again from starting 20. So like this we have done, and with 50 epochs, the accuracy we got was 76.58%. And the next and this tells the confusion matrix. We plotted the values with actual cases to the predicted cases, and if you can see, melanocytic nevi has more values, 1, 2, 5, 2 values, and the melanoma, if you can see, 92 were only correctly predicted and 120 were incorrectly predicted with melanocytic nevi. And from this matrix also we can find the accuracy, like 10 plus 59, all the correctly predicted values by total number of correct values. We get 76.585%. Then we used AlexNet model. In this, there are 5 convolution layers and 3 pooling layers. So each and every model are almost same. What they differ in was just the input size and number of convolution layers. In this, the input size will be 227 by 227, and convolution pooling, and then the 3 consecutive convolution pooling layers. So this is how we initialize the AlexNet model. Filters we use 90. This is a predefined model, so we can't modify any filter values, 96, 56, 384, 384, and 256. So like these, the images have changed. If we take 227, 227, the first convolution layer, the image size changed to 55 by 55. These are the filter images applied. So by doing this AlexNet model with the input size 75 by 100, actually we should take the input size of 227 by 227, but we have taken 75 by 100 because of the memory issues. Like in Google Colab or Kaggle, there wasn't sufficient memory for 227 by 227 into 10,015, that much memory. So we have taken this 75 by 100 randomly, and we have got the accuracy of 70.74%. This is the confusion matrix for this. The sensitivity of melanoma or sensitivity of any skin lesion is nothing but how many correct values were predicted by actual values. The next one is VG16 model. It is one of the popular models. We thought it would give the best result, but it didn't actually. So it is like 2 convolutions and 1 pooling, 2 convolutions and 1 pooling, 3 convolutions and pooling, so on. These are predefined, VG16, exception, RESTnet, and the input size has to be 224 by 224 for this to work. So like these, the image sizes are modified in each and every layer, and these are the filter images. The accuracy, if you can see, the accuracy was 65.90. This is very least. That means the model was not at all trained actually. So we took 75 by 100. We didn't have a choice. 224 by 224, it takes a lot of memory. So if you can see, it didn't actually train at all. So the next one we used was exception model. In this, point-wise convolution and depth-wise convolution, these two things takes place. Like the group of all the convoluted images and the pooling filters are combinedly joined in point-wise convolution, and in depth-wise they are taken individually and then combined. The input size we can take for this starting from 71 by 71. So we have taken 75 by 100 for all the images, for all the models. And epochs 80. Image sizes are modified in this way. These are the filter images for the exception model. Accuracy was 76.78%. So far, this was the highest for our project. And this is the confusion matrix for exception model. So in total of 2003 correctly images, only 76.78% were predicted. And this is all. This ResNet 50 is also a predefined model, same exactly as exception. The image size can be greater than 71 by 71. These are the filter images. The accuracy was 71.29%. This is the confusion matrix. So the next one is efficient model. In this, there are two models again, B4 and B7. We used B4 model. These are the filter images, and the accuracy is 76.1. The epochs we took were very less. If we have taken more epochs, the efficiency would have been greater. But the time, if we increase the number of epochs, the time take will also be greater. So we should decrease the time too. This is the confusion matrix. So far we have done all the models with this image sizes 75 by 100. Then we have done the model, custom model with the size 28 by 28. Same convolution, average pooling, convolution and average pooling, convolution and average pooling, like this 4 layers. So we have taken the starting input size as 28 by 3, and the filter size is 3 by 3. So in layer 1 convolution, after convolution, the image size is 28, and pooling, and after pooling, the image size is 14 by 14. These are the, since we have taken the image size very less, that's 28 by 28. If you can see the right bottom, the filtered images are very blurred. So the test accuracy for the custom model was 76.18%. Is the confusion matrix of custom model. So if you can see, still 128 of melanoma cases will get confused with melanocytic nevi. And then we did transfer learning to compare whether this gives better accuracy or not. So what is transfer learning? We will use a pre-trained model to get the weights from that, and then we use these weights on our custom model so that the accuracy will be increased like this. We'll use a pre-trained ResNet model. We'll be applying on the data set, and we'll get weights, and then on small data set we will apply these weights, and then we'll get the results. So for 17 epochs, it took very much time for this, with a learning rate of 0.05. The accuracy was 94.8%, which is good, but it takes a lot of time to do this. And then the dataset also contains 28 by 28 and 8 by 8 predefined data frames. So for these data frames, I have used convolution pooling layer. So this is another data set, 2 convolution layers and a pooling layer, max pooling. So if you can see, for first convolution, the padding is 1, and for second convolution, the padding is 0. So the input size will be changed to 26 by 26, and then after the pooling, the input size will be changed to 13 by 13. So these are the filter images. You can see the accuracy was 96.77%. Why is that? Because the data was uniform. In each and every skin lesion, we had around 1300 images. This gave us the best accuracy. So, and the next was 8 by 8 by 3. The same convolution and max pooling layers have used in this too. After pooling, the image size reduced to 3 by 3. These are the filter images. Since the image size is very, very less, we can see only the blurred images here. The accuracy was 97.53% for this confusion matrix. So these are all the models we have done. The training accuracy, validation accuracy, and test accuracy. And if you can see, the first 7 are of deep learning. This is transfer learning, and these 2 are predefined data frames. In first 7, we got exception model as the highest one, and basic CNN almost same, and transfer learning 94.87%. Since our project is about using deep learning methods, we chose to take exception model to our further steps. So this is all the models. So far we did all the models and found the accuracy. So now we have to do whether the image has melanoma or not. For that, we have predicted by giving the image that is existing from the dataset, no filter applied. This is blue because there is an OpenCV package which takes the images in format of BGR, but we give the image in RGB format. That is why the picture is blue. And by this prediction, it says that it is melanocytic navy with 100% probability, and the chances of melanoma are very less, 0.005%. So, and then we thought that are there any chances that if we give an filtered image, whether the prediction will be changed? So then we applied Gaussian filter. Gaussian filter blurs the image. That means it smoothens the image, reducing the noise. Then it gave us melanoma chances are 99.72%. And when we checked with the pre-existing data set, this image belongs to melanoma. So then we thought that yes, applying a filter, it gave us good chances, good results. So we started exploring other filters too. And firstly, Gaussian filter. What does this Gaussian filter does? It just blurs the image, and it is a low pass filter used to reduce the noise and blurring the regions of the image. It smoothens the image so that the quality of the image is decreased. Quality of the image is increased so that we can recognize the image. So it focuses on one point, highlighting one pixel and smoothens all other pixels. If you can see in this second picture, only it focuses one pixel and smoothens all other pixels. So then we have used Laplace filter. This is same as Gaussian filter, but in this detects the edges by giving certain values in the filter. Like if we can see the corners are less and others are same, more than corner values. After applying Laplace filter, we got the image there. Like it gave us the edge detection. So to apply this Laplace filter, firstly we have to apply the Gaussian filter, and then we have to apply that. We have to convert that to grayscale, and then we have to apply Laplacian filter. So So this is what we got after applying Laplacian filter. Since because of OpenCV BGR condition, we got this green colored images and we didn't convert it into grayscale. So directly Gaussian and then Laplace. It gave us with melanoma chances 87.61%, which is less than when we applied Gaussian filter. So we considered other filters too, like Prewitt and Sobel filters. These are almost same, but Prewitt filter has two kernels, horizontal and vertical derivative. By using horizontal derivative, we'll get the horizontal features, and vertical derivative will get the vertical features. By combining these two images, we'll get the final image. And in the Sobel filter, in this Prewitt filter, the edges are detected. But in this Sobel filter, the same process, by changing the values in the filter, it not only detects edges, but also smoothens the images. So we can see this. It detected edges, but also smoothens the image. You can see here, in Prewitt filter, the melanoma chances are 5.1723%. It said that it is dermatofibroma with 99.9% chance. And in Sobel, it said it is melanoma with 99.68% chance. So, and then we have seen the other filters like maximum, median, and minimum filter. In all those, it said it was melanocytic neve, almost 100% chance. What are these filters? Maximum filter is like if we take a 3x3 kernel in the existing image, we will take the maximum value of that and give that to the central pixel like this, 301158272. The maximum value in this array is 8, so we'll give the central pixel value as 8. This is the maximum filter applied, minimum filter, and median filter. In the minimum filter, we'll choose the minimum value and then give it to the central pixel value, and median, we'll find the median of all the values and give it to the central pixel. So after applying all these filters, we thought that Sobel filter was the best filter among the others. So we used Sobel filter for the further process. So far, yes, we got melanoma chances with the exception model. But when we observe the data, like this is the data distribution in males and females. Of course, the males are more. And in age distribution, from 70 to 75, 80 to 85, and 55 to 60 are more prone to melanoma. Localization distribution. If the melanoma is, if the skin lesion is on upper extremity, back, or lower extremity, the chances are very high. And with respect age, with respect to gender, you can see the blue is males and red females. Localization with respect to gender distribution, both in females and males, they are almost same, like they are in upper extremity, back, and lower extremity, the more chances of occurring melanoma. This graph illustrates the localization with respect to age, which is very hard to understand. So we did write small code for that. And this is the age with respect to localization in males and this in females. After seeing all this, so if we can see this first graph, okay, we'll go back. Yeah. Localization with respect to gender. There are no cases on the hand, or very less cases on scalp or ear, whether in females or males. So even the image has shown 100% melanoma, but if it is on hand, then then the chances are very low because we have never seen a case on hand. So like that, we have drawn a table. So chest, chances of melanoma in females. If the image is of chest and the age is of 40 to 45, it has very high risk of melanoma. 60 to 65, high risk of melanoma, and all other cases fall into very low. And back, 50 to 55, 60 to 60 has very high chance of melanoma. And trunk, wherever the image is from, whoever the image is from, it has very low chance of melanoma, and the next low chance of melanoma, like this. And chances of melanoma in males, the same. So this is the final detection of melanoma. Like we will give an image, and then the gender of the patient, and then the localization of the lesion, and then the age. So if the melanoma chances are 99 by the image, just by the image, and gender is female, localization is foot, and the age is 75, it has high chances of melanoma. And with the same, like 99% chance melanoma, female, foot, female, age 75, but the localization is scalp. In females, localization is scalp. Whatever the age is, that falls into very low. So there are, we have seen that there were very less cases in these categories. So there were very low chances of melanoma. So like this, we have done our project under the guidance of Padmavati ma'am. Yes, this concludes our project. And next we have to, and we have written our paper. 1 minute. So this is how we have written our paper. We have written only up to accuracy plot of all models. We should write till with starting from prediction of the image. So this concludes our project. And we have done our project using Google Colab and also Kaggle kernel. The Google Colab, it took so much time because even though it has GPU accelerator, it took so much time for us processing data from outside. But the data is from Kaggle, so I have used Kaggle kernel. It took very less time in doing the epochs, like 80, 50 epochs. We can do it in Jupyter too. I didn't try it. That concludes the project. Thank you very much.
Mr. Harish, if you have any codes, can you explain them?
Yes, yes. 1 minute. Is it visible?
Yes, it's visible.
Okay. So we have done a project in Kaggle kernel. The first stage was to import all the packages we needed and then loading the data set. Since the data set is from Kaggle, we have imported it by using this line, pandas. This is the data set, melanoma. And then the data analysis using Seaborn and pandas and also MATLAB pilot. Gender distribution, age distribution, localization distribution, all the same, just we need to change a single. And for two plots in single graph, we have to use hue. So X represents the x-axis and hue two graphs. So age and gender we have used here.
Excuse me, Mr. Hari, sorry for disturbing you, but can you explain the code step by step?
Okay. We don't write like these are all the pre-existing packages, so we just import that. And lesion, these describes that means in our data set it has the names like basal cell carcinoma, melanocytic nevi, and melanoma, and it just shorted it that to BCC, BKL, DF, and VMEL, VASC. And these are pre-existing syntax to input the data and images. Okay, the image, 1 minute. If you can see here, this is the total data set we have used. So the first two were images, and this is the first data set, and these were the small data frames. So the images are in other location, and the data set CSV file is another location. So for that, here, firstly we have taken CSV file, and then we have taken all the images here. For that CSV file, we have added the path, and then cell type like these DXA, AKIC, BCC. And then we'll come to that next, what we have done with the path. Using SNS Seaborn, we have plotted the data analysis, the count, the frequency of the lesions, and the count males and females. And these were just for data distribution. If you can see here, the second line, if it is melanoma, only we are plotting for melanoma, like we are not including any other skin lesions, so only melanoma. Just this line plots the graph. This plot we have used. There are many plots. Dist plot, bar plot 2. These are extras just for color, font size, and the labels. So if you can see here, in this line, to plot the gender distribution, have given here gender, and to plot the age distribution, we have to give just age, localization, and for age with respect to gender, we have to add another one called hue, localization and gender, age and localization, age, and now in males. This is just the data analysis. I have done this for just extra. So let's go into the code. Yes. We have added the path to the array data frame. So now we should get the images from that path. So I have added one more column named image, and getting each and every image from that path and adding that to the data frame. This takes a lot of time because there are 10,000 images and also resizing them 75 by 100. We don't know how much size the image is, so I have changed it to 75 by 100. And now, so we have to include both the target and features, like what we are making the system to learn and what it should detect. So just dropping the cell type IDX. The cell type IDX is nothing but the short forms I've given to all the lesions. That is the target, and excluding that, all other are features. So now I have splitted the data set into two ways. Yeah, the test size is 0.2, that means 80 and 20% data set. And converting the X train to array, and then we'll get Y train. So like that, the X train and Y train are found, and then in X train we'll again split that to X validate and Y validate and X train and Y train. If you can see here, the test size given as 0.1. This says that 90% and 10%. 90% is train and 10% is for validation. Again, we should reshape that. The image size, the image is initially 75 by 100, but I reshaped it into 3 channels, like RGB. I said that every image has 3 channels, right? Red, green, blue. So 75 by 100 into 3 layers, so that it will be useful later. And then we are initializing all the input shapes, number of classes, optimizers, learning rate. And then comes basic CNN model, how this model is initialized here. We can use any number of convolution layers, any number of poolings, average pooling or max pooling. We tried max pooling in another model, so here we used average pooling size with 2 by 2, and kernel size 3 by 3. We can use 4 by 4 or 5 by 5, but it gives best results if we use odd values, and it gives best results if we use 3 by 3 more. So we have used that. This code, just I saved it quickly, so there is no output for all that. We have compiled the model, and this is the model compilation. And then model.fit generator. This gives the information how the model is run for each and every epoch. I will show that somewhere it will be there. So this gives the accuracies calculations. These are all plotting and predictions. The same for AlexNet model. I'll show that one. Yes, plotting the graph, accuracy graph, and then prediction, confusion matrix. This is how we draw a confusion matrix. Firstly, we will find the predictions, and then making a confusion matrix data frame with the predicted values and actual values y test O. Heat map. This is a heat map, confusion matrix which we have found. And then the simple model 28 by 28 by 3, 8 by 8 by 3. I said there were 2 other data frames in that. These were that. So I've taken 28 by 28 by 3 RGB layer. There were grayscale images too, but I took colored images, and Y and X like target and features. Resized the images to the image is 28 by 28 by 3, so just we have to reshape it into 28 by 3. And then the data is splitted, same 80% and 20%. Just this is syntax, train, test, split. Then we use the simple model like convolution, 2D convolution, and then max pooling, 2 convolution layers and 1 max pooling. Flattening is nothing but we'll get, after here we'll get the images, like the image size will be like 75 by 100 by 3. After flattening, we'll get 75 into 100 into 3. This value will get it after doing the flattening. So yes, if you can see, yes, like this. After each and every convolution, this is the model summary. Here, flattening. So 6 into 6 into 64, this gives this value. Model dot fetch epochs. So here are, for each and every epoch, for this model, it took 1 second approximately. I have used 10. The accuracy was 95%. We can use more epochs, but it will take more time, that's it. And the confusion matrix. Yes, so here comes the 1 minute prediction. Transfer learning. We used here FastEye and the same data set with the CSV file and images, adding the path. No, these are filters. This is the overall accuracy plot. So here comes the prediction. Just there is only this line predicts whether it has what are the values, and we have to write extra code to get the exact percentage. This is without any filter, like just this CV2 package causes the image from RGB to BGR, so the image will be in blue color. Since it is another model, I have got here the different values. After prediction, like model.predict of image, will get this array. And this is melanocytic nevi, and I think this is melanoma or this one. So the melanoma chances are 0, and the melanocytic is 1, right? So it said it is melanocytic nevi with 100% chance. This was without any filter. And next we have used other filters. Gaussian, Laplace, maximum filter, median filter. Just only giving the image and mode, like whether the image should be reflected or mirrored, wrapped, and same. So this shows the Sobel filter image or another, and it said that it is basal cell carcinoma. And these are the conditions I have shown that in the table, right? So yeah, when the location is upper extremity and age in the range of 70 to 75 or 50 to 55, very high chances of melanoma, just if and else loops. Yeah. Since we used the GPU in this, it took very less time, but in Google Colab, just for one epoch, it took 1 minute 9 seconds or something. So for just 30 epochs, it took 30 to 40 minutes, which is very much long time. Yes, that's how we done project.
Mr. Harish, how did you write a project paper on your project, and how did you publish it? Can you share some tips for us?
Okay, so firstly, our guide helped us in that a lot. I'll show that. Is it visible, the paper?
Yes, it is visible.
So yes, this is just the conference paper we have sent. We should write still the journal paper. We are in progress. So this is very short, 5 to 6 pages or still less. What they see is just the plagiarism and the font and all the rules they will give while writing the paper. We should strictly follow those. So introduction, literature survey, These are the important things. Firstly, we have to write introduction, first abstract, and then introduction, and then literature survey. Then we took dataset, right? So we have wrote something about dataset and methodology, like what models we have used: basic CNN model, exception and ResNet 8 model, and results for each and every model. What were the results and confusion matrix? That's it. This was just a small paper, and in the final report too, there are some rules. Yes, writing table of contents, giving subheadings, where all the figures are. Since our project has many figures, for each and every page there are at least 2 images. So yes, this has like chapters. Chapter 1 was introduction, and then the subheadings were like melanoma and machine learning, and for again data analysis, data splitting. We use the same information from our PPT and the images too. For the font size for the normal paragraphs will be 12, I think, and for describing figures it will be 11. Even in the conference paper, I think it is 12 or 11, and this is smaller than that. This is the total paper for our first phase. Like it has 13 to 14 pages. The same as project final report. We'll give this project final report to our college, and this for conference. This for conferences. We should strictly follow the template. That's it. And I described each and every model. At last, the results, comparison of all the accuracies. And yes, the differences, what we have used, where we have researched. This is the Kaggle data set. These are all the references we have taken and learned what is, firstly we have to learn, right, what is exception model, what is transfer learning. So these are all the references. And we should extend our phase 2 for this from here, before the references, the prediction of the image and all the filters we have used. That's it. Still anything you need?
I would like to thank the team for enlightening us with their knowledge. Now the forum is open for further queries. If anyone has questions, please feel free to post it in the chat box. Mr. Harish, can you suggest or give some guidelines for how to do this project? Like, how did you start this, and what was your experience at first? Can you share that?
Yes, okay. So for major project, they gave us freedom to choose whatever we want. So firstly, our batch, we were interested in doing something regarding data science, machine learning, something like that. So we have thought of some projects, and then they asked us to choose one guide, and we have chosen Padmavati ma'am. And with her help, we wanted to do something so that we can learn from that, we can improve our skill set. So yes, this was that project. Like, we want to choose our careers in this, like machine learning in data science. So our madam projector helped in choosing this project, machine learning with melanoma detection with deep learning. And we have learned a lot from this. I mean, if we can write a paper from, if we publish a paper, it will help, it will definitely highlight our resume. Yes, we learned a lot from this.
How much time did it take for you to complete this project?
it it depends. Like, in first semester they gave us 2 days a week, and the rest for normal classes. So yes, it will take, to say frankly, it will complete within a week if we can do all the core work. But all with the presentation, we had a review twice a week, and we have to prepare for that review. Each and everyone has to say, and especially thanks for Sri Hari sir, with his help. And sir asked us many doubts, so that asking his, from his doubts we learned a lot. Like, we searched what is that, and that made us perfect. Thanks for that. And yes, if we can do it, we'll complete in very much less time. Since you'll be having the same, like a same project for 2 semesters, choose a project so that you can extend your project for the second semester. That's it.
Is paper needed for the project? Do we like? Is it really a requirement, or?
Yes, as per the rules, present rules, paper publishing is necessary to get the credits. For us, we have 6 credits each semester, so 12 credits. It is necessary with the very less plagiarism. Like, it has to be very less than 30%, including the references and all the headings. If the plagiarism is more than 30%, you will fail in that. It is necessary. And yes. And
Yours was
one more thing, you
okay.
can send your papers to conferences too, like third-party conferences. Your guide will let you know that if there are any conferences you should send your papers to. This will be a plus point. This will be a plus point for your project. Yes, we have done one conference like that. ICCI, and we are looking to publish our paper too.
Your project was a very big one, so how did you like reduce it to fit it in that paper? It was like the PPT, comparing the PPT and the paper, the data, and how did you do that?
Yes, the PPT is approximately 100 slides, but those were just the images we got from our code, like data analysis and all the confusion matrix, the same images. Just taking two images in one column, that will just write. They don't just see the matter you write, they'll see the images too, whether they are plagiarized or not. So demonstrate your own skills, like present your own images, don't just copy from the internet, like that.
So, what do you think about the plagiarism that is running on these projects these days?
Mm, we can say it like two things. One, some may say they cheat, or some may say that they learned. I will say that they learned from existing one. So try to write something you learned in your own words. Just paraphrase those words. That's it. So the plagiarism will reduce eventually. If the pictures are from your own code, and if you paraphrase the sentences with the headings and the references, it would definitely be less than 30%.
I would like to thank our seniors, Mr. Harish, Mr. Kaushik, Mr. Pratap, and Mr. Karthik for taking your time out for the webinar and helping our attendees to have an understanding on how to build their final year projects. I appreciate everyone enough for their involvement and their willingness to join the session. I hope everyone had a great evening. Stay tuned to IEEE GRIT SB for another interesting session, which will be conducted in the next week with another project and a new team of seniors coming from CSC.
Thank you, and I hope the presentation went very well too. Thank you for this opportunity.
So till then, take care and stay safe. Thank you.